So today we're continuing with section 4. I know it says day 3 because that's where we started, but really this is now day 4 of the lesson 4. So we already saw that we should always look for a GCF first, no matter which type of problem you're trying to factor. Whether it's a binomial, a trinomial, or 4 terms, 5 terms, always look for a GCF first. Now on Monday I told you we were going to skip over these on Monday, but today we're going to talk about these patterns. Now for the quiz yesterday there were 3 patterns you had to memorize. Here are 2 more. Okay, these are going to be perfect square trinomials. And the answers are always going to be a binomial squared. And we're going to see these in action. Always remember, multiply your answers back or FOIL it in the case of these binomials to see if it makes sense. FOILing is going to save you. Okay, if it doesn't go back to your original problem after you multiply everything, then you've done something wrong. So these were the examples we did on Monday. So again, factors of 4 that add to give you 5, and those factors were 1 times 4, because also 1 plus 4 gives you 5. So 1 times 4 is 4, but 1 plus 4 is 5. So again, you make them into binomials. Write the first term, you square root it, and put an x and an x, and then you put the 1 and the 4. So these were all the examples we did. If you missed any of the examples, there is a video on Canvas, on YouTube, that you can watch to see all of these worked out. All right, so here we go with the more challenging trinomials. And here we have a leading coefficient, or our A term, that's not a 1. Now, there are all different kinds of factoring techniques out there. Some books will teach you to guess and test, and then do a whole bunch of different FOIL problems until you find the one that works. I'm going to teach you a really cool trick that I like. It seems to work. Now, some of these small ones are easy if you wanted to do the guess and test. And when you do guess and test, what you're doing is listing all the factors of the first one, all the factors of the second or the last term, and then this is actually a 1x and a 3x, and then you have to find out what combination, taking like this one with this one, and this one and this one, until you can get a 7 in the middle. Now, this one was pretty basic. It was easy. And I think just the way I set it up, putting 1x with 1 and 3x with the 2, let's see if that works. Oh, I don't think it's going to work. But let's try it. Let's FOIL it. So this is how you would do it if you were listing the factors of the first term and the last term, and then find the ones that when you FOIL them, give you your original problem. Now, notice when I do this one, I don't get a 7x in the middle, so it does. Never mind. It does give me the 7x, so I got lucky and I got it right away. Okay, that is the guess and test technique. I'm going to show you a way that I like to do that seems to work it'll work every time, and it seems to be a lot easier. So. Okay, I think I jumped to the answer. Never mind. Thank you. That should have been a 3x, and the 5x was here. That one failed. All right, so now what I need to do is rearrange it. So now I'm going to instead try the x and the 2, and then I'll put the 3x with the 1. So see how now I'm switching these two. So now if I FOIL this, 3x, 1x, 6x, plus 2. Now I get the 7x. Thank you. I'm glad you guys are awake. Okay, so the correct binomial is x plus 2 and 3x plus 1. So notice when I put the 1 with the x and the 2 with the 3x, it didn't work. So this is how some Algebra 1 courses teach it to guess and test, to list all the factors of the first term, all the factors of the last term, until you find the one that'll FOIL together. Now, I'm going to teach you a different technique that I think is a little bit easier. When you're factoring, I don't care what method you use. I know there's a couple other ones. I used to teach one that I would name slip and slide, but that one got kind of difficult. So I'm going to show you the one that I'm using now when I review with my geometry honors. So I'm going to teach it to you guys. So here's the original problem, 3x squared plus 7x plus 2. Now, in some books they teach you multiply. Remember, standard form for a quadratic is ax squared plus bx plus c, where a, b, and c are just going to be a number. It's going to be a constant. So in this case, my a value is 3 and my c value is 2. So to use my technique, I'm going to multiply the beginning and the end, and I'm going to get 6. I am looking for two numbers, just like I did before with the easy trinomials, two numbers that multiply to give me actually 6x squared, but also add to give me 7x. So I need to list the factors of 6. So it's 1 times 6 and 2 times 3. But of those, because it's positive, positive, I can see that I need the 1 plus 6 to get the 7. So I'm going to do 1x. So my factors here will be 1x and 6x. And then here, 1x plus 6x gives me 7. Everybody with me on how I found those factors? All right, now here's the trick. I'm going to take the first term here, and I'm going to write just without the exponent, a 3x at the beginning here, and a 3x at the beginning here. Then I'm going to take the two factors I just found, and I'm going to put them here. 1, and I'm going to put, so the x's are coming out of the 3. So really what we're doing is just finding the factors of 6. Everybody with me so far? So when I put them in, I'm only using the numbers because I've already placed my x's with my 3x. So I've split this right here, but no exponent. Now at this step, we have to look to see if there's a GCF. Is there a GCF from this binomial that I could simplify it? No, right? I can't divide it. My GCF is 1. So then this one stays the same. What about the second one? Can I divide this by anything? By what? By 3. So just like we did on the quiz yesterday, I'm factoring out a GCF of 3. And then what I'm going to write here is x plus 2. And then I throw away the GCF. Yes?
Wouldn't if you multiply 3x times 3x, wouldn't I get 9x squared?
Okay, this is why, okay, so this is a little bit problem with the trick is when you first set it up, yes, it gives you 9x squared, so that would be a clue to you that, wait a minute, I have one more step, I need to reduce one of the binomials. So that's the problem with this is in the trick, when you the first step you make, it's not accurate. It doesn't give you the first term. But if you try to FOIL it and you see that it's not giving you that, that tells you that one of my binomials, or maybe even both, needs to be simplified. Does that make sense?
What's the GCF on the 3x plus 6?
3. Because 3 divided by 3 is 1x, or 3x divided by 3 is 1x, and 6 divided by 3 is 2. Is this making sense a little bit? Let me do another one. Again, that's the difficulty here, because at this step, when you first set it up, yes, 3x times 3x is not 3x squared, it's 9x squared. But then that's your clue that, wait a minute, I still have another step, and I needed to reduce this, and then it gives me something that foils. So in the final step, after you pull out the GCF, then it'll foil back. Let's try number 11. So again, here I'm going to multiply, and I'm again looking for the factors of 6 that give me 5. So again, plus plus, again, that's telling me my signs are the same. So it's either going to be 1 times 6 or 2 times 3. But the one of these that I'm going to choose is the one when I add 2 plus 3, and it gives me 5. So when I set up my binomials, again, take the first term, and you write it at the beginning of both. And then what we're going to do is put the 2 factors. So it's going to be plus 2, plus 3. Now I have to look at them. Can I simplify one or both of the binomials? Is there a GCF in one of them?
Yes.
The first one I could divide by what?
2.
Okay, so then when I divide this by 2, it turns into x plus 1. And this one I can't, so I just drop it down. Now if I FOIL this, it should go back to the beginning problem. So let's try it. X times 2, 2x squared. X times 3, 3x. 1 times 2, and then 1 times 3. Notice when I add the middles, it does give me 5x in the middle, and then plus 3. So I did factor it correctly. And again, the order of the binomials does not matter. You could put the 2x plus 3 first and the x plus 1 second. Now, some Algebra 1 courses teach you to factor by grouping, which is really tedious. When I taught it to my Algebra 1 students last year, I taught them first factor by grouping, then I showed them the trick. They were not happy that I did not show them the trick first. Everybody getting the hang of the trick a little bit? I know it's a little off at the beginning, but it works every time. Let's try the next one. Yes?
What is this? So you're supposed to, for this one, multiply the 6x and then add to 5x? Is that what it is?
So you're multiplying to get 6, but add to get 5, yes.
How come you're not using the variables in this one, but in the other one?
Well, it made it kind of hard, so don't use the variables. Let's just take the coefficients and multiply. I think it'll be easier to see. Because we're going to pull the variables when we pull in that first term and we split it. So let's try this one. Let's go ahead and do beginning times n, so a times c, and I get 15. I'm looking for factors of 15 that will give me -8 when I add them. Notice again, this last term's positive, but the middle term's negative. To get a positive, I know my signs have to be plus plus or minus minus. Yes, question.
No, it's really
Okay, tell me.
I mean 3 and 5, but that positive negative thing kind of is confusing.
Okay, so again, we need 2 numbers that are going to multiply to give me a positive 15, but who will add to give me -8. So 2 numbers that'll multiply to give me positive 15, but the same 2 numbers that add to give me -8. Hannah?
-3, -5.
Perfect. So when that last term is positive, that should be a big red flag saying, wait a minute, my signs need to be the same. And then in this case, whatever's in the middle is your clue, and that's what both signs are going to be. So -3, -5 gives me positive 15, and then when I add them, I get -8. So now I'm going to, again, take the 3x, write it at the beginning of both. Notice I'm not putting 3x squared. I take away the square, and I'm just putting the coefficient and the variable. Then I'm going to put the 2 numbers I just found, and again, the order doesn't matter. Yes?
I was going to do the next step.
Okay, what do we do?
For the first one, you can take out 3.
Good. And what does it become?
X minus 1.
Perfect. What about the second one? Can we do anything?
No.
and then drop it down. Now at this step, this is where you should FOIL it. If it doesn't go back to the beginning, you either simplified wrong or maybe you picked the wrong factors. Okay, if at the red step here, if you try to FOIL this, it's not going back to the beginning. So right away, again, you need to stop and think. Did I not simplify? Did I pick the wrong factors? What did I do wrong? So here if I FOIL, I get 3x squared minus 5x minus 3x plus 5. And then when I add them, I do get the negative 8x in the middle and the positive 5 on the end. Making sense? Yes?
How did you know that you had to multiply those two to get positive 15 and add them to get negative 8?
That's always the process. So you always take the two ends, you always multiply them, and that's the number you're looking to get the factors of. And they always, the factors you come up with, have to always equal the middle.
Okay.
Always. Let's try another one. So again, first step is to multiply. So 2 times 7 is 14. So I'm looking for two numbers that are going to multiply to give me positive 14, but who will add to give me negative 15. Yes?
Negative 14 and negative 1.
Beautiful. Everybody see that? Again, this last number is positive, so that's telling me I need same signs. And then the same signs I need are what's in the middle. Okay? So now, rewrite the 2x at the beginning of both, and then put in the two numbers you just found. Again, it doesn't matter if I put the 14 first or the 1. So again, I need to simplify. Which one can I simplify? What can I divide it by? Perfect. So this one rewrites, nothing to reduce, and then here, x minus 7. At this step, FOIL it. I know you guys don't want to do the extra step, but it's going to save you. So multiply and get 2x squared. Outside gives me negative 14x. Inside gives me negative 1x. And last gives me positive 7. When I add the middles, I do indeed get the negative 15x that I was looking for, and then drop down everything else. So it worked. So here is my final answer in blue. Getting the hang of the little trick here? Now, some people are good at guess and testing. You can also, list the factors of 2, factors of 7, and find the ones that fit together. Okay, I can sometimes look at them because I think of factoring like puzzles, and I got to figure out which numbers are going to fit together. So you can do the guess and test method, but sometimes it'll take a whole bunch of foilings, especially when you get numbers like 36 or 24 that have a lot of different combinations or a lot of different factors. Let's try 14. Again, process is the same. I'm going to multiply the beginning and the end. This time, my end number is a negative. So when I multiply positive 5 times negative 1, I get negative 5. What does that tell me about the signs of my two numbers I'm looking for? What do they have to be? Different signs, positive and a negative. So I'm looking for two numbers. So right away, I already know when I set this up, one's going to be negative, one's going to be positive. So the two numbers that will multiply to give me negative 5, but who will also add to give me positive 4. So it matters which number gets the negative sign. Okay, so here I know there's two ways to get a negative 5. It's either 1 times negative 5 or negative 1 times positive 5. But again, remember, you're trying to equal positive 4 when you add them. So which one of these, the red or the green, when I take those factors and add them, will give me positive 4? Green. The green. So notice negative 1 plus 5 equals positive 4. So that's what I'll put here. The negative 1 goes with the subtraction sign, and then the positive 5 goes with the plus sign. And again, we need to look at the problem. Is there a GCF I can pull out of my binomial? Is the first one good? This one? Yes. What about the second one? What can I pull out? 5. And then it becomes x plus 1. And then we're going to FOIL it to make sure it goes back. So if I take my 5x minus 1, let me just write it over here so I have room to FOIL. So first, outside, inside, and last, when you group the middles, it does give you positive 4x. A little hint, the middle sign goes on the bigger factor. So see how the middle number here was a plus sign? And see how my bigger number in the factor here was positive? That's a little trick. Question? Yes, up front.
So basically when you're taking the GCF out, you add everything
Right, we throw it away. Yeah, so before when we did the quiz yesterday, we needed to hold on to that GCF and put it in the answer. When I'm applying this trick, we're throwing the GCF away. So this is why some people don't like this trick, is because number one, when we first set up the problem here, it's not going to FOIL back and give me a 5x squared. It's going to be 25x squared. And then the second thing is when I pull out this GCF, I'm throwing it away. But the trick works, and it seems to be a lot simpler than some of the other techniques out there, especially when your numbers get really large. When they're small like this, and 5 only has 2 factors and -1 only has 1 way to make it, you could probably guess and test pretty quickly. Everybody with me so far? All right, let's see what's next. All right, another example. What's my first step? Multiply, beautiful. Okay, so again, we're gonna multiply the beginning and the end, and we get -15. So I'm looking for 2 numbers that multiply to give me -15, but who will add to give me the middle, which is -2. Yes?
-5 and 3.
Beautiful. -5, +3. Again, the order doesn't matter. So again, write the 3x at the beginning of both, and then put -5, +3. And again, we got to look to see if we can reduce. The first one will not reduce. The second one will. And then at this step, you should FOIL. If it doesn't go back, either you've picked, maybe you put the positive with the 5 and the negative with the 3. This FOILing would catch it. Now, sometimes you're going to have to simplify both. All of the ones we've done so far, only one needed to be simplified. But sometimes both of them could have a GCF. Let's try number 16. What are we going to do here? Multiply. So we're going to do 21 times 8, or -21. So then I get 8. Now this one's kind of big. 168. Now, sometimes what I do is I take the 2 numbers that I just multiplied and I sort of list the factors. And then I try to find the ones that maybe are going to fit together. So see, like if I do 4 times 3 and 2 times 7, that's going to give me 12 times 14, and that's going to give me the 168. And then if I make this one negative, it'll work. You see, guys, how I did that? So that way I didn't have to list. Now, some people don't like doing that. What they do is they're going to do 1 times 168, 2 times, and I need my bigger number to be negative, 2 times -84, and do a nice organized list until you find them. Now, notice this middle number is kind of small. So that's a clue that I know my numbers that I'm going to pick, my factors, have to be 2 apart. So if I multiply, just to double check, 14 times 12, just want to make sure that I did that correctly and see if I did pick the right number. Once I multiply it, these two numbers do multiply to give me negative 168. So my two factors, if I would have kept listing them, I would have had to go down quite a ways, but finally it would have been 12 times 14, and the 14 would be the negative. So now I'm going to set up my binomials. This one's actually, both of them are going to have to be simplified. So I'll take my 8x, the beginning of both, and then put in the two numbers I just found. Everybody with me so far? All right, so now at this point, I need to reduce both. Yes?
For the first one, 4.
Okay, good. And then I'm going to get, again, you're going to throw it away, so 2x plus 3. And what about the second one? 2. So then 4x minus 7. Again, once we divide them, we're throwing away those GCFs. So let's FOIL it. Let's double check that it does go back to this thing. So if I FOIL, I get 8x squared, negative 14x, positive 12x, and then negative 21. When I group the middles, I did get what I needed, so I picked the correct factors. So 2x plus 3 and 4x minus 7. It worked. The best way to do this is to practice. Get your hands on as many factoring problems that you can. It will make things a lot easier. All right, now we're going to look at, nope, still we got some more to do. We don't have the special cases yet. All right, next one. Bless you. What's my first step? Multiply. Now, also remember that we should always be looking for GCF first. If I could divide all of these by a number, I would, but none of these so far had a GCF. All right, so yes?
What would you do with the GCF if you had one?
Then,
Get rid of it?
no. In this case, if you're going to divide out something first, you have to put it in the answer. The only time we're throwing it away is when we're doing the trick to simplify our binomials. All right, so this one I'm going to get 72. So I'm looking two factors of 72 that when I add them, give me negative 18. So this is telling me this last number is positive. Oops, I did this backwards. Okay, let me change the answer here. So I'm multiplying to get positive 72, but adding to get negative 18. Now, you could start your organized list. Notice that both signs are going to be negative to get a positive answer and to get a negative in the middle. So negative 1 times negative 72, negative 2 times negative 36, and you can keep listing until you find the one that's going to give you negative 18. Or you could even break it down. So like if I take what I first started with, the 9 times 8, 3 and 3, 2 and 4, and I can see if I can maybe make a combination. That's a 6 and a 12. There you go. So 6 times 12 is going to give me negative 72, and when I add them, I get negative 18. So sometimes these little factor trees will work, and it'll help you to find the factors faster. So my factors are going to be 6 and 12, and they're both negative. And now I have to look to see, can I reduce my binomials? Can I reduce the first one? What can I divide it by?
3.
Good. So divide it, and then I get 3y minus 2. And then this one I can also simplify by the same thing, and then get 3y minus 4. And then throw it away after you divide it. So then now we're going to FOIL it and make sure it goes back. 9y squared. Outside gives me negative 12y. Inside negative 6y. And last gives me the positive 8. when I add the middles, I do get negative 18y, and then I get that one. Good? All right. Let's see number 18. Again, no GCF that I could pull out, so I'm just going to begin. Yes?
Negative 1 and 30.
Okay, so I'm going to multiply negative 1 and 30, and I get negative 30. So I'm looking for two numbers that multiply to give me negative 30, but who add to give me 1. So when I have to try to get a 1 in the middle, this 1 AM, I know that I'm going to have numbers that are next to each other. So what times what gives me 30 that's next to each other?
6 and negative 5.
Good. So my signs had to be different. So negative 5, positive 6. Everybody with me on that?
You can't do negative 1 and 30.
No, because that'll give you, if I do negative 1 plus 30, I get 29. And I'm trying to make a 1 in the middle. So negative 1 times 30 will multiply, but it won't add to give me that number in the middle. All right, so now I'll set up my binomials. 30a at the beginning of both. Now notice this has an m here. So here when I add in these factors, negative 5 with an m and positive 6 with an m. And now I need to reduce both of them. I can divide this one by 5 and this one by 6. So this becomes 6a minus m. And this one becomes 5a plus m. Throw away the GCFs. And then if I FOIL it, I get first, outside, inside, and last. And then when I group the middles, I do get the 1 AM minus m squared, and then drop that one down. And you don't have to put 1 AM, just put AM. And it worked. Now we're going to look at the pattern for the perfect square trinomials. All right, so these are patterns you can memorize. If you can recognize that the ends of the problem are perfect squares, like we did yesterday with the difference of two squares, it makes the problem a little bit easier. We can still use the technique I just taught you, where you multiply the ends and find that the number that adds to the middle, but there's a pattern to this, so you can memorize that it's x squared, and then if you multiply the x and the y and then times it by 2, it should be the middle term, and we're going to see that. All right, so if you look at this problem and you look at the 16 and you look at the 25, and if you can realize that 16, when you square root it, it's 4, it's a perfect square. Same thing with the 25, it's also a perfect square. If after you square root them, if you multiply them, 4 times 5, and then double it, if it gives you the middle number, then it's a perfect square trinomial. And the trick is you just take what you got when you square rooted. So 4p, you square root that, you square root that, and it's the same number both times. It's a binomial squared. And my signs are wrong because I needed a negative 40. So it's going to be minus 5, minus 5. So whatever sign's in the middle will tell you the sign of your binomial. Now, if this confuses you and you're not good at recognizing perfect squares, then we can use the same technique we just did, where we're going to multiply 25 times 16 and then find all those factors of that huge number that will give you negative 40. So it is in your best interest to be able to recognize perfect square trinomials, just like you could recognize the difference of two squares and the difference in sum of two cubes. So this one, the result when you factor a perfect square trinomial is a binomial squared. And again, we could FOIL it to make sure it goes back. So if I FOIL up here, I'm going to do 4p times 4p, outside, negative 20p, inside, negative 20p, and last, positive 25. When you add the middles, it did give you the 40 and drop down the 16p squared. So it did check out. So my answer can either be written as 4p minus 5 to the second power, or you can keep them separated. And we have one more example, and then we're going to go over the quiz. I need to slide down. Here we go. All right, so again, if you can recognize that 9 and 4 are perfect squares, you're going to square root the 9, square root the 4, and then if you do 3 times 2 and get 6, and then double it, if it gives you the number in the middle, you know this is a perfect square trinomial. So then you're just going to square root this, square root this. So remember, when you square root variables, we're dividing them by 2. So this will become 3mn. And then you're going to put the square root of 4, which is 2. And it's going to be a plus sign because that's the sign in the middle. You can write it twice, or you can write it as the binomial to the second power. So whenever you can recognize you have a perfect square trinomial, then you can do this. Now, let's say we didn't recognize it. Let's say you're thinking, oh, it's just a random trinomial. I'm going to do the long way. And you can do that. Multiply the beginning and the end. We get 36. I'm looking for two numbers that will multiply to give me 36, but who will add to give me 12. And I can see that that's going to be 6 and 6. And then I'll do the same process with the trick. But if you recognize that it's a perfect square trinomial, it's a lot faster by square rooting the ends. So if I were to set this up, mn plus 6, 9mn plus 6, it's the same on both, simplify, and then when I reduce 3mn plus 2, 3mn plus 2, and you're done. Same answer. So you can use either technique. So those of you who are good at recognizing perfect squares, definitely test out. I recommend you FOIL because sometimes the ends will be perfect squares, but they won't give you the correct middle term, and then you have to do it the long way. So make sure you're careful. All right, so that is the end of the trinomial part of R4, so that completes R4. Your homework tonight is page 43. You're doing 23 through 39 odd. Any questions on the trinomials? Again, the solutions are already on Canvas, so you should be checking your answers tonight. And then tomorrow when you come in, if you have any questions, I'll go over the homework questions. But tomorrow we are moving on to lesson R5.